Okay, let's get started with activity one, recalling ways of solving. Now we kind of reviewed this a little bit in the intro, and I did that because we want to be able to use those processes to solve these equations. Now these are a little bit different because they contain numbers that are not whole numbers. But that does not change at all the procedures we would use for solving them. So let's look at A. Problem A, 0.07 equals 10m. So this means 7 hundredths is equal to 10 times m. So this is no different than the examples we looked at in the intro. My unknown is m. I'm going to solve this equation by getting 1m all by itself on one side of the equal sign, but I've got 10m. So the way I want to solve this is by dividing both sides by 10. And again, I want to use my fraction bar to represent the division, and that's kind of one of the things we're looking at a lot in this lesson. So I also need to divide the other side by 10 because I want to always keep my equation true and balanced. And the way I do that is by whatever I do to one side of the equation, I have to perform the same operation on the other side. So on the right side, this is pretty straightforward. 10 divided by 10 is 1, so I have my 1m. I don't have to write the number 1. If I just see m by itself, it's understood that it's 1m. But on the left side, I have a decimal divided by a whole number, which can get a little trickier, but it really isn't. Don't let this throw you. There's several different ways I could evaluate this expression. One is I could convert my decimal to a fraction. If I read this properly, I know we lots of times read it as 0.07, but if I read it properly, my decimal places are tenth, hundredths, so this is really 700. So I could think about this as being 700 divided by 10, and then using my idea of keep, change, flip, I can write my 10 as a fraction, improper fraction, and do my keep, change, flip, so it becomes 700 times 1 over 10, and now when I multiply straight across, I get 7 thousandths. 7 times 1 is 7, 100 times 10 is 1,000, and then if I want to change that back into a decimal, 7 thousandths, thousandths would be the third decimal place after the third decimal space after the decimal, so it would be 0.007. Another way, if you remember, anytime we are multiplying or dividing by a power of 10, we can do it simply by moving decimal point. So I could do 700 divided by 10 means the decimal point is going to get moved one place to the left. So again, I get 7 thousandths or 0.007. So don't let a problem like this, which looks confusing, throw you. Think about it. This is just 7 hundredths divided by 10, and then you can think about the different ways you might evaluate it. All right, now our next problem, I made a typo. So you're going to need to make a correction before we do this one. It should not be 0.1. It should be 10.1. So you can just squeeze a 1 there in front of the 0. So that should be 10.1. I started doing this video before I made the correction and realized my error. So now this is the other structure where we have variable plus a number equals another number. And again, we want to get the variable all by itself. That's how we solve the equation. So I need to eliminate the 7.2 on the right side of the equation. Well, it's being added. I can eliminate it by just subtracting it. But then I need to do the same thing to the other side of my equation in order to keep this a true and balanced equation. So again, on the right side, easy peasy, 7.2 minus 7.2 is 0. That just leaves 1p on the right side of the equation. Now I just have some decimal subtraction. So with decimal subtraction or addition, I just want to make sure I'm keeping my decimal point lined up. I can't do 1 minus 2, so I'm going to borrow. I'm going to make this 10 a 9, and the 1/10 becomes 11/10. So 11 minus 2 is 9. My decimal point slides right down, and then 9 minus 7 is 2. So my equation, my solution is t is equal to 2.9. And I could always check that. That's one thing about solving equations, is you can always take your answer, substitute it back into the original equation, and see if you get a true equation. So 2.9 plus 7.2, is that going to equal 10.1? And if I want, I could just come over here and check it. 2.9 plus 7.2. 9 plus 2 is 11, carry the 1. 1 plus 2 is 3, plus 7 is 10. So I get a true equation. And I could also come over here and try that. Is 10 times 7 thousandths equal to 700ths? Well, instead of dividing by 10, I'm multiplying by 10, so I can move the decimal point one place to the right, and I would get 0.07. So that checks as well.